Okay, so I realize the fan's on. I realize the door's open. Shh, that's not an invitation. That's not an invitation to keep talking. It just simply means that it's hot in here, and we just have to deal with the heat. But so be it. This goes over there on the other side of you. So we went ahead and spent the first half of class looking at those proofs, using CPCTC, making sure you know if you're given all the statements and reasons jumbled up, can you order them? Can you know what to do here? Now, once the statements and reasons are given to you like that, sometimes it's easy to fill them out. You will, on your congruent triangle test, have one proof to finish from top to bottom, on your own, completely with nothing in it. Okay? It's only a 4 or 5 step proof. It's a shorter proof. It's a pretty easy one. But you do have one to finish on your own completely. You will also have one or two others where I'll give you some statements or reasons, and you'll have to fill in the rest of the blanks. They're all very similar to the ones that you did today. Okay? So if you kind of understood what we did today in terms of using definition of segment bisector, definition of midpoint, vertical angles, all those kinds of things, reflexive property, there was quite a few of those in there. Once you get there, then hopefully we can fill out the rest. I was proud of how many of you remember that CPCTC always goes at the end, right? Because what we're trying to prove after the triangles are congruent. So that was really good. The next half of what we're going to do today is we're going to look at coordinate geometry to prove triangles congruent. This is guaranteed always, always on your SOL. Okay? So I have a couple of examples that we're going to do. I'm going to turn the lights down. I'll try to make this a little bit bigger. I want you to copy this exact picture, if you could, onto your coordinate geometry paper. All right? So I'm going to make these points a little bit. If you could, Celia, would you flip those lights down for me? Thanks. A little easier to see, I think. So I think this is -2, 3. I'll just write the coordinates at the top, okay? This is -4, 0. Yes, on your graph paper, I want you to copy these pictures down. And -1, -2 down here. And then W is the 0.24. X is the 0.1, -1. And Y is 4, -3. All right, so just copy those two triangles right on a coordinate plane, and we have to decide, based on this picture, whether or not the triangles are congruent. Okay, and we're going to have to prove it. So give you a second to copy it down first. Yeah, it doesn't appear if you look at them just by looking at it visually, just by kind of casually looking at it. They don't look like they're the exact same shape, do they? So it's probable that they're not congruent. When we have triangles on a coordinate plane like this, can you think of, we only have 5 choices now. In this case, what is the only reason that we could use between SAS, SSS, ASA, AAS, and HL? What's the only way that we could show the triangles were congruent? Side, side, side. Okay? Because they don't have vertical angles. I know nothing about the angle measures. I don't have any right angles at all. I only can decide the lengths of the sides. That's it. So if I was going to try to prove the triangles are congruent, I would use side, side, side. Which means, what formula am I going to be using? The distance formula, exactly. So that's kind of where we are here. We got to use the distance formula a bunch of times. As soon as I get some that don't show they're congruent, then I can stop. And I can say the triangles aren't congruent because these corresponding sides are not. So maybe we should start by looking at that. Which sides look like they're going to correspond to one another? Let's kind of highlight them here. What does AB look like it's going to correspond to over here? It's kind of hard to tell. Maybe this side, maybe this, I don't really know. Let's find some distances, okay? Let's find the length of AB. And let's find the length of XW. Do you remember how to do it?
Like the square root of x 2 minus x1 squared plus...
Yes. Subtract the x's, the difference of the x's squared plus the difference of the y squared. Exactly. So let's do that. So let's look at A and B. So I have the difference of the x's, -4 and -2. So -4 minus a -2 becomes a positive squared. And then we'll look at the y coordinates, 0 and 3. 0 minus 3 quantity squared. Just plugging in what we know. This is what you're going to have to do. Okay? On your test, you're going to there's a whole section on your congruent triangle test where you have to show triangles are congruent on a coordinate plane. Use the distance formula. There was actually one very similar to this on your quiz that you took. Do you remember that for extra credit? There was an extra credit part of the quiz. I'm going to give that back to you on Wednesday. Okay? Once everybody has taken it, then you can have it back. So what does this simplify to? 2 squared, or -2 squared, plus -3 squared. So what is that? 4 and 9, square root of 13? Is that right? All right. Let's do the same thing with xw. 1 and 2, we need to subtract those and square them. And we need to subtract the x's, the y's, and square them. Definitely not congruent, would you agree? Maybe AB corresponded to XY. Don't you think we should probably double check that? It could be. Maybe one's flipped around. That happens sometimes. Okay, India, I don't know why you have your phone out, honey, but it shouldn't be out. Why don't you put it away totally for me? And write down what I'm asking you to write down here. So let's add XY. Let's find the length of that one just to make sure that it's not congruent to that one. So I want you to tell me what the length of XY is. I got the square root of 13, didn't you? So what does that mean? I have a pair of congruent sides, don't I? Uh-oh. All right, so let's go ahead and color code. So I know that AB and XY are congruent. All right. So let's see if we can find another square root of 26. Let's find the length of AC? I don't know. Let's see if we can find that one. So AC. So we really are going to have to find all the lengths, aren't we? So we're going to find AC. We're going to have to find BC. So go ahead and find what's the missing one on the other triangle here? XY. Oh, no. YW. So go ahead and take a second and find all 6 of those sides. And let's see, because I do have a pair that matches. So I got to be careful. Not 26, but the square root of 26, didn't you? So the length of AC is the square root of 26. Uh-oh. What does that mean? We have another pair of congruent sides, don't we? All right? So we have that AC and XW are the same length. All right? Does that guarantee the third ones have to be? And they're not, are they? Okay? What is the length of BC? Square root of 13, again. So it's an isosceles triangle. Okay. So square root of 13, and then what did you get for the last one? Square root of 53. Did y'all get that? Seems a little high. Yes. YW, let's see. So I have 2 minus 4 quantity squared plus 4 minus a -3. And it looks like you're right. So I have 7 squared, which is 49, and then I have another 4, square root of 53. Since these are not congruent, what does that tell me? Triangles are not congruent. But look at how far we had to get to till we figured that out. Right? A lot of work. Here's a type of question you might see on the SOL. You know how on your SOL they have like a little arrow that you can click on certain parts of the graph and that kind of thing? Well, here's a question you might see. I got a bunch of different triangles up there, and it says click on all of the triangles that are congruent. Okay, let's highlight them. There's possibly more than one pair. What kind of triangles do you see here? Right triangles. Okay, that's helpful. Why is that helpful in coordinate geometry? Hang on. And when the two legs, since they're horizontal and vertical, what does that mean? I can just do what? I don't even have to do that. I could, absolutely. I can just count. So I don't have to do the distance formula here. A little bit nicer, isn't it? Okay? So let's count. Let's find the lengths of all the sides. And I agree with you that, well, we'll continue. So let's find the length of this one. So this height is 1, 2, 3. This is the side, has a length of 4, right? How about the bottom, the base? It's 3. So let's go and find all the lengths of all the sides. This one would be 2. This one is 4. Okay, but those are definitely not congruent, would you say? And then over here we have 3 and 3. Nothing congruent to each other yet. Let's try down here. 3 and 4. Okay, we got one. How about over here? 3 and 4. And because these are all right angles, why are these triangles congruent? What would the reason be? Nope. Triangles are congruent by either side, 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 angle, angle, HL. Nope, I don't know any of these hypotenuses, actually. It is side, angle, side because these all right angles are congruent, aren't they? Now, Deshay, I could have used, was it India who said it? I'm sorry. India. What I could have said is the Pythagorean theorem, and then that would be side, side, side. So we would know all the sides, right? But those are the 3 that you would have picked. Again, more than one answer, right? To show that those are the triangles that are congruent. Could you do that? You could pick them out. You will have a part on your test where you will have a picture like this. They may or may not be right triangles. If they're not right triangles, lots of distance formulas. Don't you agree? Hopefully we'll have some right ones, because if it's horizontal and vertical, you can just count. Guaranteed on your test. Okay? All right, last part of what we're going to do today. You don't have to copy this down, but I want you to watch or just listen, kind of focus. I realize it's so hot in here. I get it. But you're going to have some overlapping triangles. And anybody who sat at that far table over there, where Eric's table back there, and did that proof when there were some overlapping triangles in that situation. Not all of us made it to that table, so I kind of want to make sure we talk about it as a class in general. You will have a section on your test that only deals with overlapping triangles. So those of you who sat over there, what was the first thing I told you to do? When your triangles overlap, what do you need to do? Separate them. And I always want you to do that, okay? Figure out what's in common. So when I say words like common side, oops, I'm going to try making it bigger here. There we go. Triangle ABC and triangle ADC. I have no picture, but I can tell what the common side is. How? Well, it's got to have 2 letters. It's AC, because AC is in common to them both, isn't it? So AC is going to be the common side. How about here? What's the common side of the next one? Because WZ is again in common. Good. And then the last one, RT. Pretty easy. So even without a picture, we should be able to look for what these overlapping triangles would have in common. So let's look at this particular picture. And this is a common picture. Notice it does have overlapping triangles. We want to figure out triangle ABD and DCA. Now, I've got a lot of triangles going on in here, so it's important to highlight and figure out where those 2 are. ABD. So I'm going to kind of just highlight it here. ABD is this big triangle right here. Would you agree? I need to draw it separately, so I'm going to do that. ABD. Okay? Now I'm going to go ahead and erase what I drew on the overlapping part and look at the other one. DCA. And that's this guy here. So I'm going to look at DCA. What side do they have in common? They share a D, okay? So we know by what property, by the way, is that? The reflexive property, because it's what they share, what they overlap. Anything that happens is congruent to itself. So that would be AD. Good. All right. So this looks very similar to the proof that was over there at Eric's table. Okay? So I've got it kind of sort of filled out down here. Don't worry about your no-need plan thing. We're just going to fill it out. I'm given a pair of triangles are congruent. I don't think I've ever given you that before. I gave you that. Look at the given. So let's fill it in. All right. Who wants to go in and fill in the rest of statement 1? Come on, y'all got to get up. You're yawning. You're doing it. Here we go. Come on. Number 1. Let's go fill out the second half of the first statement. Okay? I'm going to call on the second person. Let's see who I can get. Huh?
I like your nails.
Oh, I don't. They did a terrible job this time. They're all peeling and everything. I can't tell. It's a good thing sometimes. All right, India. Pick one. Oh, you picked 3. Pick one. Oh, she does not in the class anymore. Between these 2. All right, who's that? Oh, she's already up there. Andrea, she's up there. This was the other person. Simon, you're next. Okay? So, ACD is congruent to BDC. Very good. Excellent. All right. So, look at the reason for statement 2. Corresponding parts of congruent triangles are congruent. What does AC correspond to? Go ahead, Suman. Look at the congruent statement. Who wants to draw the triangle separated? Nobody? All right, Lucia, you can go ahead. You can do it at the same time he did. Go ahead. Does AC correspond to BD? It does. Good job. High five. Awesome. So she's drawing triangles ACD. We're separating them a little bit. Always a good idea. All right, so now I have statement 3. Amira, you're up. What does angle A correspond to? Great, okay. So I have that AC is congruent to BD. I have that angle A is congruent to angle B. You with me so far? Notice what triangles Lucia separated. She showed the ones that were given to me as congruent, right? But if you notice the flow of the proof, these 2 triangles aren't the ones they're asking us to deal with, and that's okay. This is one pair of the overlapping triangles. There are some others that we're going to deal with. Look at the 4th statement. Look at the reason. What does it say? Do I have vertical angles up there? BED. BED is this guy right here. What does it correspond to? AEC. Good. Now, do I have do I have a pair of triangles are congruent already? Another pair? Notice what pair I have this time. I have this pair, don't I? Which are different from the ones that Lucia drew up there, aren't they? So sometimes when you have overlapping triangles, you have several different pairs of triangles we need to deal with. What is the reason that these triangles are congruent? Angle, well, it told us. Oops. But you should have been able to look at the picture. So what's the other triangle here? BED corresponds to, try again, AEC. Good. All right. Now, what I'm asked to prove is CE and DE. Do they correspond? Do CE and DE correspond? So isn't CPC, TC the reason there? All right, good. So what you guys are going to have to work on tonight, I'm going to give you some problems from the textbook to work on, some of which, there's going to be one problem that's like this with graph paper. I could only find one in the book. So you have one to do, and then you have some overlapping triangle stuff to deal with, okay? So let me go ahead and tell you what your homework is going to be. It's going to be in the textbook. So if you have 15 minutes, if you want to go ahead and start using it now, you can. But it's kind of odd, the picture. So on page 226, it's not an exercise. It's called the Getting Ready Solve It problem. So the first thing you're going to do is on page 266, you're going to do the solve it, get it ready. It's one problem. And then you're going to do page 268. Hang on, I think that the 266 is not what it was. Sorry guys, it wasn't 260, it's 226. I apologize. Page 226. All right, and then 268, I want you to do problems 1 through 14 all. Now, it's not that many problems, but number one, because it's one of those, it's a coordinate geometry one, there's going to be a lot of distance formula stuff. So that's why I didn't give you that many problems of these overlapping ones, okay? Good enough? All right. If you want to grab a textbook, feel free.